Hey guys, Mr. Backwork here. In this video, we're going to look at exponents and the product rule. Now, before we get too far into things, let's remind ourselves what exponents really mean. So if we're looking at something with a second power on it, what that really means is here when we have a to the second power, or if we read that a squared, that really means that we're taking a and multiplying it by another a. So having an exponent means that you're multiplying something by itself however many times based on what the exponent is. So if we looked at a to the third power, or a cubed, that would mean that we're taking a times a times a. And we would need three a's being multiplied together in there because of that third power. So if we want to look at something like a squared times a cubed, let's use what we just talked about. A squared really means that we're taking a times a, and then we're going to multiply that by, well, a cubed means that we're taking a times a times a. So what we've really got happening in here is 5 different a's being multiplied together. And using what we know about exponents, since we have 5 of the exact same thing being multiplied together, we could write that as a to the 5th power. So in general, what's happening, we've got this thing called the product rule that says when you're multiplying things together that have powers on them or exponents on them, you add the exponents together, but you keep the base the same. And this rule only applies if you are multiplying things together where the base is exactly the same. So in that last example, each of those had a base of a, so when we multiplied them together, we could just add those powers. We had a squared times a cubed, and if we add those together, we get a to the 5th power. So if we take a look at this example here, we've got y cubed times y to the 5th. So we notice that both of those have a base of y in them. We're multiplying these together, so our product rule says that we should add those powers together. So we leave the base the same. We've got a base of y. We're going to add those exponents together. So 3 plus 5 gives me an 8 power. So the final answer here is y to the 8th power. Or if we look at this example, we've got p times p to the 8th times p squared. Now we've got 3 things being multiplied together. We're still going to check the bases first. All of these are base p. Now we're going to look at the exponents. The first one doesn't have an exponent on that, so that means that there's an implied power of 1. Then we've got this 8, then we've got this 2. We're going to add all those powers together. We leave the base the same, so we've got p. Add the powers together. 1 plus 8 is 9, plus 2 more is 11. So we get p to the 11th power. Taking a look at this next one, we've got negative x to the 4th times x cubed. Don't worry about that negative right now. I'm going to focus on the x's. We've got the same base in here, so when we multiply these together, we're going to add the power. So 4 plus 3 is going to give me x to the 7th. Now that negative, our first x was negative, and our second x was positive, and when we multiply a positive times a negative, we always get a negative answer. So we get negative x to the 7th. Now this next example is a little bit different. It says that we're going to use the commutative property to solve this one. So we've got 2x squared times 5x to the 6th power. The commutative property says when you have multiplication everywhere in your expressions, which we really do, because 2x squared really means 2 times x squared, and 5x to the 6th really means 5 times x to the 6th. The commutative property says that you're allowed to rearrange the multiplication, and it doesn't change the answer at all. So what I'm going to do is I'm going to take all of those numbers and just move them out to the front. So we've got a 2 and a 5. We're still supposed to multiply those together. And then I'm going to take those variables and I'm going to keep those on the end. So we have x squared and x to the 6th. And again, we still have multiplication between all of those. Now we should be able to do this 2 times 5. 2 times 5 is going to give me 10. And now on the back end here with these x's, now I can use my product property with those exponents. So we've got a base of x, so I'm going to leave the base the same, and then we're going to add these powers together. So 2 plus 6 is going to give me an 8 power there. So we would get 10x to the 8th as our final answer. This next example is very similar. So we've got negative 3x to the fourth and negative 7x to the 0 power. Again, I'm going to use that commutative property to rearrange the multiplication in here. So I'm going to take the real numbers and put them out front. So we have the negative 3 and the negative 7. And then I'm going to put my variables on the end. So x to the fourth and x to the 0 power. So if I take negative 3 times negative 7, that's going to give me positive 21. And then if I take x to the fourth times x to the 0 power, well, we're going to add those exponents together. So we're going to get x to the fourth power. So we get 21x to the fourth power as our final answer. Now this next one, again, very similar things happening. Now we've got three pieces though. So we've got 3x squared times 6x cubed times 5x to the fifth power. I'm still using my commutative property, so I'm rearranging the multiplication in here. So I'm going to take all of those numbers out to the front. So we're going to have 3 times 6 times 5, and then I'm going to put all of those variables on the end. So times x squared times x cubed times x to the fifth. Now I'm going to multiply all of those numbers together. 3 times 6 is 18, and then 18 times 5 is going to give me 90. Now we've got all of these x's in here. So we've got x, and if we add up all those powers, 2 plus 3 is 5, plus 5 more is 10. So we get 90x to the 10th power. One more example that I want to take a look at here, and notice we've added an extra variable in there. So everything that we've looked at up to this point has just been a single variable, but now this one has both a and b in it. We're still going to use the commutative property to rearrange things, but now we're going to be extra careful about how we rearrange those variables. I'm still going to take these numbers and move them out to the front. So it's going to be negative 7 times 3. Now we're going to go in alphabetical order. So I'm going to do the a's first. So we've got a to the fourth times just a regular a, and then we'll deal with those b's secondly. So b to the fifth times b to the sixth. Now, if we multiply these numbers together, negative 7 times 3 is going to give me negative 21. Now, because these are different variables in here, we need to treat them separately. So we're going to deal with the a's first. So we've got a to the fourth times just a regular a, and remember that means an implied 1 power on there. So if we add those exponents together on the a's, we would have a to the fifth power. And then if we take a look at the b's, we have to deal with the b's separately since they're a different variable. But again, we can add those exponents together on those b's. So 5 plus 6 would give me b to the 11th power. So when you're using your product rule, you add up the powers on the things that have the same bases. So we added the powers on the a's to get a to the fifth, and then we added the powers on the b's to get b to the 11th. So our final answer is negative 21, a to the fifth, b to the 11th. That's going to be it for this video. Thanks for watching.